The next assemblies we're going to be discussing for Watts are the 800 series of pressure vacuum breaker assemblies. I say series because there's an 800, there's an M2, M3, and an M4 we're going to want to discuss. As Watts modifies their assemblies, they use the M designation for a modification, and they're presently up to the 4th modification. There was no M1, just went right M2, M3, and M4. So the original version was the Watts 800 series, which was produced from about 1982 to about 1993. Here's what the 800 series assembly looked like. Ball valves with the test cocks mounted to the body, which I'll show you the difference when we get to the M designations. Canopy on the top. Again, that's what the body looks like. Here's the internal parts with our check assembly, disc retainer, disc guide, disc holder, disc spring, check spring retainer, air inlet bonnet, poppet, and the spring and the bonnet assembly and canopy. So those were the parts in the 800 series. And again, this was produced from about 1982 to about 1993. Early 90s, they started having a lot of problems with the air inlets being stuck shut or opening below acceptable minimum of 1 pound. And they tried a lot of different things trying to get it to stop. One of the things they tried doing was epoxy coating the bonnet where the float disc sat to, and other things. And then they finally just decided to remodify it and go up with an M2, M3 series. And let's take a look at those. The M2s and the M3s appeared different on the outside of the body. As we see here, it had a brass canopy on the smaller size. M3, M2s had a plastic canopy on the top, but the bodies even look different. This version of the M2, M3 was an upgrade of the 800 series, which they had troubles getting the air inlet open reliably. The check mechanisms were very similar. That same spring retainer design with that spring holder inside the body. What was different that they changed was obviously because of the air inlet problems. And the air inlet, they went from a flat rubber disc to seal on the air inlet to an O-ring design, minimizing the amount of contact, which we'll show you when we take the assembly apart. So the dramatic difference between the M2 and M3 versus the 800 series, the check mechanisms were very similar, but the air inlets were dramatically different to help alleviate the problems they had with relief valve air inlet opening points below 1. The M4 designation was the same M2 and M3 design as we saw earlier. The only difference was that the M4 incorporated a replaceable check seat. So the 800 series was the original version. M2, M3 were the modifications that took place that changed the air inlet to have a more reliable air inlet opening. And when they went to the M4 designation, they used the same internal parts as the M2, M3, except they went to a replaceable check seat so that it had a replaceable check seat design. So 800, M2, M3, M4. We're going to combine these together in our repair process and go ahead and take them apart. So let's see what they look like. Here's a cutaway of the 800 series pressure vacuum breaker, the original one. Easy way to tell the difference is the test cocks were mounted on the body as opposed to the M2, M3, M4 design where the test cocks are mounted on the shutoffs. But anyway, canopy came off the top. Canopy is an important part of this assembly. As we've said many times before, it makes things don't fall inside the body. Some people just consider it a splash guard, but it also keeps things from falling inside the body. The bonnet assembly unscrews from the top. It's a brass body here and a brass bonnet. And to unscrew it, required use a crescent wrench, something like that, to break that brass on brass bond. And on the 2-inch size, it got very hard to remove that sometimes because of that brass on brass bond that would happen to it. Whenever you go to remove a brass on brass bond nut bolt combination like that, it's not so much a strength issue. In other words, I can put a crescent wrench on here and I can put the strongest guy in the world on this. It wouldn't necessarily be a strength that would do it. It's a shocking action. In other words, hitting it like that is what makes sure that the bonnet comes off. Obvious problem with that is the piping system that this is attached to. You don't want to use that shocking action if you've got an old piping system, galvanized, rusted, ready to break. But that's the action you need to remove that brass on brass bond. The bonnet assembly is screws from the top. The air inlet spring is set at the factory, and there is a little little lead seal that's placed on the top of this stem, because you'll notice that this stem can unscrew out of here. And if I take that out, I can remove that air inlet loading, or I can actually change that loading, how it'll affect it on certain travel by moving that in and out. So the factory makes sure it's not adjusted in the field, puts a little lead plug right over the cover there, sets this at the factory. Float assembly comes out next. Floats in one piece. They use a flat rubber disc as the air inlet disc, as you see right here, made out of silicone. Replacing the disc is just a matter of stretching it in and out of the holder, making sure it's all the way back into the retainer, just like that. Now for the check mechanism. Here's the part that causes the problem. Use a spring retainer. It looks like this. By pushing down, rotating at 90 degrees, releases the spring tension, like that. Then the spring retainer will come out from the top. Spring, check assembly comes out next, just like that. Check seats are cast into the body. One screw holds the disc into the disc holder. Reassembles, a matter of putting it back together. After we change the disc, putting our spring back in here. It's a good idea to take that spring and just put a little tension on that clip. It'll hold inside the check body, which makes it a lot easier to get it back inside the body. So now we want to get the spring retainer in place, and the function of that spring retainer is to push down on that spring. Keeping this perfectly flat is critical to make sure the load on our retainer is pushing straight onto the disc holder. So we're going to insert it in from the top, pushing down, rotating 90 degrees, making sure that the spring retainer is sitting flat underneath the clips here and on the back side here. Making sure it's flat just like that assures that we're pushing down equally on that spring and giving us our loading. Now, the air inlet, float assembly, we changed our disc. Bonnet assembly, O-ring on the outside. Reinstall back into our body. Allows us to reassemble. Again, it's an O-ring seal on the top, so the bonnet does not have to be overly tightened, yet unfortunately, because it's a brass-on-brass bonding, a lot of times that removing it gets to be a problem. Don't forget to put your canopy back on top. That's the 800 series. Now, the problem they had with this design, and led to the revisions, had to do with this air inlet assembly. The air inlet assembly sits like this, and you notice it's a relatively wide disc area relationship to the air inlet seat. And what happened on a regular basis is the spring loading, which was in this stem right here, made it so that the air inlet did not come off. And hopefully nobody adjusted it in the field, which they didn't because of the lead plug. But anyway, you can see the movement I have there. Anyway, it would be like this, and what would happen is the silicone disc would literally bond to the seat. And as the air inlet went to open like this, the disc would not come off of the seat. If you remember in our pressure vacuum breaker test procedure, not only do we get the point where the air inlet opens like that, but what the next step is that we have to drain the body, right, to make sure that the poppet drops all the way down. Well, guess what? In the 800 series, it didn't drop all the way down reliably. So they wanted to come up with a way that the air inlet wouldn't be bonding to that as hard. First thing they tried doing was what was called a polycoater, actually a polymer coating that they put on the brass bonnet itself. The thought process was if they had a smooth surface here, it wouldn't bond as it would to the brass body. So sometimes you may see some of these bonnets where it looks like it's got a plastic gray coating on the bonnet. Those was one of the attempts they tried to make the air inlet open more reliably. They still had problems with it, and that's what led to the M2 and the M3 designation. So let's kind of take a look at the M2s and M3s real quick, starting here with our M3. You'll notice that the check design is almost identical to what we just saw in the 800 series. That same spring retainer with the 4 clips, obviously a little bit smaller, so we won't bother worrying about that. But let's take a look at the air inlet. So here's the air inlet off that M3 original designation, the M3 designation. The screws came off the top, canopy came off, air inlet assembly, and air inlet spring. Now remember, with the 800 series, we had that large flat disc with the large seat. Notice this being a 3/4 and this being a 3/4. Same, look at the difference in the air inlet floats. The old 800 series, it was much larger, and the problem of bonding to that bonnet happened quite regularly. So they went to a smaller bonnet area. They also went to, instead of using a disc, they actually went to, I can get it off, an O-ring design. And we know that an O-ring is easier to seal than a flat disc. Also, if you notice up close here, that the seat is not flat now. It's chamfered or at an angle. So as that O-ring goes to seal on that chamfered area, just like that, because O-ring's got to sit in a slot, remember? It sat right there and had a more reliable air inlet opening. So this seemed to eliminate the problems for Watts. And in the M2 designation, the larger sizes, A little bit different looking than the 800 series, but similar. The whole bonnet unscrewed, same basic design using an O-ring as we saw in the M2. So this was the change. Original 800 series, M2, M3 designations like this. The check seats were cast in the body. The check mechanism was similar to the 800 series like I've already showed you. So what led to the M4 designation was the adoption of a replaceable check seat. So in the M4s, it's the same internal parts as the M2 and M3, except their seat was replaceable, and here's what the 2-inch M4 check seat looks like, sealed in by an O-ring, screwed into the bottom of the body. So the original 800 series had problems with the air inlet opening. They fixed it with the M2, M3 designations, giving us the more reliable air inlet opening by going to an O-ring design on the air inlet. Not only did they go to a O-ring design, remember how the guiding mechanism, you always hear me talking about guides, on the old 800 series was the single one through the center, where the M2, M3 designation had the 4-pronged guide and had the air inlet spring like this. And the M4 designation incorporated the replacement of the check seat so that it was a replaceable check seat unit. So that's the 800 series pressure vacuum breakers, M2, M3, M4. The only other point that I wanted to show you was there's an M4 FR. FR stands for freeze. And if you look up very close, here's a version of the regular air inlet, the white one on your right, on your left, and the FR version, which you see here in the center. What they added to it is the centerpiece here. And what the centerpiece is a relief valve. You'll notice there's a small little round, almost like a BB shaped in the center of a disc, and a spring underneath. This was installed to make the FR series to make it a freeze-resistant pressure vacuum breaker. When freezing occurs, what happens is, as we mentioned earlier in the seminar, water will expand about 9%. The 9% expansion increase in pressure. That increase in pressure may rupture that body, which is what we're trying to avoid. And the old version, again, what would happen, the body ruptured, you'd have to replace it. So they thought by changing the poppet with this relief valve in the center, is that as it sat like this, that when freezing pressures happen and that pressure increased right there, that it would sense that pressure increase, open up this relief valve and relieve that pressure in a freezing condition. So the air inlet assemblies are different. You can see here's the standard one, and here's the freeze version of the FR. So that's the 800 series. Original 800, M2, M3s, and M4 with the replaceable seats, and M4 FR with the freeze protection. Those are the pressure vacuum breakers from Watts. The next assembly we're going to discuss in the Watts world of pressure vacuum breakers is the 800M designation and the CM designation. We've talked earlier about Watts models and the M meaning a modification that took place on the specific assemblies, but this is one time that the M was used for a different interpretation, and the M stood for medical. So this is an 800 pressure vacuum breaker medical valve. The CM is a chrome-plated medical valve. It was used where a compact design was needed for installations. Medical applications, meaning like in wall enclosures inside of walls of surgical suites and places like that where they wanted a very compact body design. Here's what the medical version of that pressure vacuum breaker looked like. First and most unique thing was that the shutoff valves were integral or built into the body of that assembly. So this portion here had to use a crescent wrench to turn the ball valve. And then in the stem of the ball valve handle was a needle valve, which was our test cock. So in our handle, we had the handle to shut the ball valve off, and we also had a needle valve test cock instead of the standard quarter turn type test cock. So here's a schematic drawing showing of that particular assembly. The same basic check mechanism as we saw in the 800 series, and the air inlet assembly is similar to what we saw in the 800 series, not the M2, 3, or 4 designation, with the flat air inlet disc. Here's the exploded view showing you the integral built-in ball valve stem. There's the ball for that stem, and in the center of that stem was our test cock. Check assembly had that quarter turn rotation of the spring retainer to hold the check in place, and the air inlet screwed out from the top. So let's go ahead and take the 800M CM assembly apart real quick, see what it looks like inside. Here's what the 800M version looks like. This happens to be a CM because it's chrome plated, so it's the 800CM version. The M is the same thing except it's a bronze body. And again, the M was for a medical application, and it was meant to put into compact installations where pressure vacuum breakers had to be installed in areas like inside utility boxes and walls or someplace where they wanted something very compact. Anyway, first and foremost is how do you shut it off? No, the ball valves are not missing. The ball valves are integral and built inside of the body. You can check ball in here. The stem on here sticking out is my wrench flat. In other words, here is where I grab it to turn the ball valve. By putting my crescent wrench on that point, turning it quarter turn, it operates just like a ball valve. This outer portion, if you notice, is a needle valve, and that's where my test cock is tapped. So my test cock taps all through the center of the ball valve stem for my test procedures. So that's for testing. That's the ball valve for shutting it off. There is no handle on this model. You have to use a crescent wrench to turn the handle on and off. Okay, so that's what it looks like. Let's go ahead and take it apart now. Take the cover off, canopy off from the top. 2 screws come off. Same basic bonnet mechanism as we saw in the 800 series. Air inlet spring, which is not set at the factory, it's a loose spring. Our air inlet disc poppet assembly comes out next. And that check assembly is the same as we've seen in the 800 series with that quarter turn rotation with the 4 guides on the check. So here's what the air inlet assembly looked like. The disc stretched in and out of the holder, just like that. And bonnet assembly. Reassembly is going to be just the reverse. Get our disc back into the holder. Bonnet assembly back with the poppet. Have it ready to go back into the body. And tighten it back down, O-ring seal, canopy on top. That's our 800M, or in this case CM model of assembly. Again, the tag was held on by 2 little screws and fell off quite frequently, as this one's almost ready to do. So a visual indication of this was necessary, and a lot of times, because unfortunately you'd walk into it and look at it and not sure what it was from those ball valve handles and the test cock sticking out. So that's the 800M, in this case the CM version.